For problem number 12, similar to number 11, we're taking a piece of wire that's 10 meters long, and cutting the wire and forming an equilateral triangle with one piece of the wire and forming a circle with the other piece of the wire. So conveniently using 3x for the length of the wire that we use to make the triangle, and then since it's three sides of the triangle, each side has the same length, and that would be x, and then we can see that half of the base is x over 2, keeping in mind that and then the rest of the wires used to make the circle. So let's take a look at the area of a triangle. We know that the area of a triangle is 1/2 the base times the height. Excuse me. In a equilateral triangle, we have each of the angles is 60 degrees. So that's 60 degrees there, 60 there, and 60 up here. But that 60 gets split. That's a 30 right there, and that's a 90. So inside this triangle, inside the equilateral triangle, we have a right triangle. That's a 30, 60, 90 right triangle. And if you remember from geometry, the shorter leg of a 30, 60, 90 right triangle is opposite the angle that's the smallest angle. Shorter leg opposite the 30-degree angle. The longer leg is always the shorter leg multiplied by radical 3. So we have the radical 3 times x over 2 would be the length of would be the height of the right triangle here, which would be the height of the equilateral triangle as well. So in other words, the area of the triangle is 1/2 the base, which is x, so the base being this whole thing, x over 2 multiplied by the height of the right triangle, x over 2 times the square root of 3. Can we clean that up a little bit? Let's write that as radical 3 over 4 times x squared. So when all is said and done, we have the area of the equilateral triangle. Now, we want to come up with the area of the circle, and we know that the area of a circle is pi r squared. Now, to get the radius, we have to figure out, well, since the wire 10 minus 3x was used to make the circle, that's actually equal to 2 pi r, the circumference of the circle. So if 2 pi r is 10 minus 3x, that means that r, if we divide both sides by 2 pi, is 10 minus 3x over 2 pi. So that's the radius of the circle, and the area then of the circle in terms of x would be pi times the radius squared, and the radius is 10 minus 3x over 2 pi squared. And that is the area in terms of x of the circle. But when all is said and done, what we really want is for part A, express the total area enclosed by the pieces of wire as a function of the length x of the side of the equilateral triangle. So the area in terms of x, this is the area here of the triangle. So that's radical 3 all over 4 times x squared, plus the area of the circle, which is pi times 10 minus 3x over 2 pi squared. That is a big time problem right there. That is the area of both the triangle and the circle.